Welcome to another episode of my phases 143. This time around we are going to talk about projectile motion. So, in projectile motion there is this common and known formula that we all know, which is your distance is equal to your ut plus half at squared. Usually they represent the u, which is the initial velocity, by v naught, which you can also denote it as any letter depending on how you want to solve it. So let's move straight into what we are coming to do. In finding or using the projectile motion, for instance, you can be asked to find, let's say, the distance. When you're talking about projectile motion, the word projectile means you are actually projecting something into the atmosphere. We are ejecting something into the atmosphere under the gravity or under the free fall. It should be under the influence of gravity. There is no way you throw something into the air and the thing will forever stay there. By all means, it will come down, unless maybe you are using a rocket where you are actually moving out of the influence of the gravity. For that one, the moment you escape the gravity, you will not be able to be pushed down. So now, this is the direction of gravity. Our gravity operates downwards. So this is the direction of gravity. And now, when you throw something upward, this means that what? Gravity is what's going to act on it. And gravity is not going to act in the same direction. Gravity is rather going to act in the opposite direction to your object. For instance, if you are standing here and you make sure that you projected something above or you projected something into the atmosphere, you will see something like a projectile. Projectile, in an essence, that this will be the maximum point. The maximum height is actually the height or the distance, the farthest distance that the object can move before it returns back into its trajectory. So the distance from this side, this will be your maximum height. So this one be your maximum height. Then initially, when you were projecting the thing was actually what? 0. The thing was at 0 meter per second. It wasn't moving before you projected it. So your 0 meters per second. You get it? So from this equation, you could see that if you are projecting something, initially the thing was at rest and you projected the thing, then your 0 times your time will still give you 0. Any number multiplying 0 will still give you 0. So you can derive your new equation as S, which is your distance, is equal to only half times your gravity, then your t squared. And this is only used when you are dealing with downward motion. Downward motion, in an essence, that assuming you were standing at this edge and you threw the object directly down, you didn't throw it up for gravity to actually push it down. You threw it downwards. So if you are throwing something downwards and gravity is also acting downwards, back in vectors, what did we learn? We learned that when something are moving in the same direction, then automatically it will be positive. But when you throw something, that's why you are having your gravity to be what? To be positive G. Now, when you are having a situation where you actually throw the thing upward, and your gravity is also acting downwards. Then in this equation that you are going to use, we used the formula, your distance is equal to your negative half, then your gravity times your t squared. Why are we saying negative? The negative is coming from the gravity. You are going to have a negative gravity, which is negative 9.81 approximately. That is the value for the gravity. Now, so to move on with. Alright, so moving on to, let's look at this particular object. Let's say this one is object B. Or let's call this one a ball. Let's say we are having a round ball or a tennis ball. When you project this tennis ball, or when you use a stick to actually hit it and it's moving upward. Remember, we are talking about projectile motion, so it's actually not directly upward, but it's rather moving in a trajectory. So when it is moving, back in vectors, we all have, if the thing is moving at a particular speed, let's say this is the trajectory in which it is following. At the end of the day, you can draw your tangent to give you your resultant. So this will actually be your resultant. Let's call this one VR, and this one will be your Vx, and this one will be your Vy. So you see, so in anything at all, it is having what? The y component and the x component. So if you want to find a direction, automatically there will be a direction here. Now there is one thing I want to tell you, that when you project an object, let's assume that this is the same ball that you've drawn here. When you project this ball, the higher it goes, the lesser its y component. So you could see that from here you are having your y component, you are having your x component, but by the time it will reach this point, you are only having your x component without any y component. So that is how it is. And you could know that because we are talking about the velocity aspect of it, at this particular point, being the maximum height, you are not going to have any y component, so you are only going to have your s component throughout. Then as it comes down, so if you are having an object this way, now it has reached this particular point. As it is coming down, you are going to realize that your upward, the y component that was actually up, is now in the negative y direction this way. Negative y direction, which is your Vy, and your Vx will still remains the same. Then still you can find your resultant, which is the Vr, and here will be your Vx, which is your x component of the velocity. So that is to tell you that the Vx, it actually remains constant. It's only the Vy that actually decreases as it reaches its maximum point, or it reaches its maximum height. So looking at this diagram, let's assume that there is also a projectile motion here, where we've actually projected an object under the influence of gravity. Now, you projected the object, and now this is the final position of the object. So final position, let's say position O or position A, this is the final position. The distance that it actually took you for, or the distance that it took the object to be projected from its initial point. In this initial point, you can actually trace it to be here. So let's say this side is x, position x. So from position x to position A will actually be the distance that the object actually covered. So distance is given by, is from position x to position A. In terms of meters, this is the distance. Then, if you are asked to find, let's say, the distance that the object covered, the distance is actually the vertical component. So you are talking about the distance that it's covered in a vertical direction, then you are talking about the maximum height. And I've already discussed earlier with you that from this point directly downwards is the maximum height. And you know that at this point, the only force that is acting on this particular ball or this particular object that has been projected is mainly your gravity. So from the formula, velocity is equal to your distance divided by your time. Then you can actually find the distance that it actually took, or the distance that the projected object actually used from its initial point to the final point. Same way, we can also calculate for the velocity at which the object will have before it lands. Remember that when you project your object and you project it, when it gets to this side, your velocity here will be 0 before it starts coming down again. When it starts coming down, the thing that will be bringing it down is gravity. If there is no gravity, then this means that when you throw something upward, then you should expect the thing to actually stack. But that's not how it works. The moment you throw something, something brings it down. So what brings it down is what we call the gravity. So we can find the velocity. So at here your velocity is 0. Here your velocity is 0 doesn't mean your acceleration is also 0. So that is the other point that you should also note, that it's not always that you're having your velocity being 0, for that matter acceleration too is 0. Here the force that's acting there, or the acceleration that is here, is what? Acceleration due to gravity. And you know that acceleration due to gravity is always 9.81 meters per second. So the velocity that will be here, let's say v a, velocity here, velocity at this point, and velocity at, let's say, vc. Now when you are comparing the velocities, you are going to realize that the vc will be having what? The smaller value as compared to the vb, then as compared to the va. So you can see that this is a trend, and in this trend we are having what? Increasing velocity or increasing speed. Increasing speed. So the same way you can also apply it to your time of flight. You can, assuming you are having your time, the time that it actually took the object to be projected from this side to the ground, and they ask you to find a distance, then your distance will actually be equal to what? Your velocity times your time. Already you know the velocity that the object used, or it took the object to be projected into that maximum height and back to the ground. So in case of finding the maximum height, to find the maximum height, we also use this same formula, but we include the height at which you projected the object. So this is that if you are able to find the maximum height will actually be this point. That will be the maximum height. So if you are trying to find the maximum height above the ground, then the height from this point to this side, then plus your height of the building or the cliff that you are actually standing on. So let's call this one y. So your y plus your maximum height will give you the total distance, that is what? The total distance of the object from the ground at the position where your v is equal to 0, and the position where the thing has reached its maximum height, you are going to find your velocity being 0. When it is returning, its velocity will be increasing again. So at this particular point, the only thing that is present here is acceleration due to gravity. So always keep it in mind for projectile motion and never miss it. Let's look at this particular question, which was somewhere in the slides. They were asking you you are having 2 points, or you're having about 4 points. You are having point P, you are having point Q, you are having point R, and you are having point S. And they are asking you that using this velocity time graph, at which point are you going to get your maximum acceleration? So this one is actually velocity time graph. We can also say using your distance and your time graph, your distance and your time graph, will actually give you velocity, and your velocity time graph is the acceleration. So always keep it in mind. Here you are seeing distance is to time. You are plotting a distance against time. Automatically you are getting velocity. The slope will be velocity. If you are plotting velocity against time, then our slope will give us what? Acceleration. So let's use distance against time. Here we are talking about velocity. So on these 4 points, at which point are you going to get your maximum velocity? In order to get this, we actually draw a tangent. Tangent is actually a straight line that touches a curve at only one point. So if you are trying to draw the tangent for P, you can just do something like this, and this one will give us our tangent. So when we find this slope, let's say we are going to find the slope for M1. This one is what? Line 1. So you find the slope for line 1. You also find the tangent. So if you are drawing a tangent, the tangent will somehow be straight. And if you are using your graphical brain, if you are having a tangent that is like a straight line, horizontal, then this means that what? Your slope is what? 0. So you are having your M2. Automatically your M2 will be 0. And if you are having this one, if you are drawing a tangent, the tangent here, you are going to have a certain line, and this line, if you try finding the slope, this slope will be the largest. So M3, this slope will be the largest because it is the one that is having what, or it is very steep. Any line that is very steep is having a higher slope. And this one too, if you are trying to draw this the tangent again, you are still going to get a tangent which is what, M4, and this M4 will be equal to 0 because the line is still vertical. So if you try comparing, remember that the slope is the same as the velocity, so you are just going to find the slope of all the lines so that you use it to determine which one is the greatest or which point is having the greatest velocity. So you are going to realize that this one, with your graphical brain, you are going to get a slope that is what, lesser than the R. So using your simple analogy, you are going to realize that your M3, which is your slope 3, which is the same thing as what, your velocity 3, will be the highest as compared to, so from velocity 3, then you are coming to velocity what, P, which is what, the velocity 1. Then before you compare the Q, so here, because you're having straight line and a straight line horizontally, you can have your vein. Your vein 4 is equal to your vein 2. Remember that the slope 2 and slope 1, the slope 2 and slope 4 are all the same. They are all straight lines. So if you try finding the slope, you are still going to get what, 0. So this is that on this plane graph, the one that you are going to have, or the point that you are going to have a maximum speed, is actually what, point R. So the same thing applies to the projectile motion that I was talking about, that at this point your velocity is 0. If you try throwing something into space, or if you try throwing something into the atmosphere, you are going to realize that it will reach a certain point, it will stop, then it will start coming down. The point where it will stop will be the maximum height, and at that point that it is going to stop, we are saying something has stopped, it is having no speed. Its speed is 0. So the same thing applies to what we are doing here. So I've explained everything. Watch out for my next video on the continuation of projectile motion, where we are going to talk about, or where we are going to talk more on the circular motion.